So we talked about multiplicity and of how we can have bounces and slides, but we could also have these zeros that don't touch the x-axis. So before we kind of slid that vertex so it just touched the x-axis, but these vertices can actually not be on the x-axis. So what happens then? So what happens when these two arms don't cross the x-axis? Well, we have an example here, x squared plus 4, y equals x squared plus 4. This has got a vertex at 4 and it opens up, so it does not cross the x-axis. So it doesn't actually give us any real solutions. And why is that? Well, if we actually try to solve this, it's because we end up with solutions that are what we call imaginary numbers. Okay, so if I solve this for x, I have to put the minus 4 on that side. Square rooting this, I end up with the square root of negative 4. Well, this is what we call non-real solution. Okay? This is an imaginary number, or not a real number. So these non-real numbers is when we have the discriminant less than 0, so we're square rooting a negative, okay, and we end up not crossing the x-axis. So these also occur when we have cubic and higher orders. And we end up with these non-real solutions, and these non-real solutions are these bumps that don't cross the x-axis. Okay, so we have a negative x minus 3, so we have the solution at positive 3. But this x squared plus 1 is a non-real root. Okay, so it gives us this shape here, and it doesn't give us a real solution. So we can't actually solve it. Now, one thing about these though is that they do come in pairs. Okay, we cannot just have one solution. So and physically that can't happen either, because we can't just have one arm that doesn't cross. To make this not cross, we need a bump, and we need two arms here, so we need to have a pair. So non-real solutions have to come in pairs. Okay, they come in quadratic pairs. And although we can't solve this, we can still find that quadratic factor. And this is what we're going to do next. So we can find these non-real factors, or non-real quadratic factors, by division. Okay, we can just divide, because if I have this real root and a non-real root, in this case here, when I multiply this out, I end up with, x times x is x cubed, negative 3 times x gives me negative 3x squared, x times 1 is 1x, negative 3 times, this is when I FOIL this all out, this is what I get. So this is my expression. If I want to find my non-real factors from this expression, what I can do is take that expression and divide by the real factor. Okay, this x minus 1 that gives me the solution, I can divide by this, and then I'm going to be left with my non-real factor. Okay, in this case, it's my x squared plus 1. So this is a non-real factor that has no real roots. It's got a discriminant bigger than 0. If I actually tried to solve this, I wouldn't be able to solve this because it's like a quadratic that does not cross the x-axis. Okay. So the way we're going to find these then is we're going to find one real solution and divide to get the non-real solution, or the quadratic one. And it has to be quadratic, and remember that these non-real solutions have to come in pairs, so they come in these quadratic pairs. So let's try one of these out. Okay, we're going to find the first solution by graphing this. Okay, although we could guess at this, we're going to start using this strategy. We're going to graph and look at these graphs, because it is important to know what these graphs look like anyways. So we're going to use these graphs to find solutions. So when I graph this, okay, I'm going to put this in my graphing tool, and I'm going to end up with a graph. And my graph kind of looks kind of funny, but when I put this in my graph, it looks a little weird. Okay, I don't really know what to make of it, because it looks like this. It just comes through like this. I don't even see the other parts. If I expand my window, so I'm going to make my y min maybe negative 200 or something like that. Okay, now I see something. Okay, so I'm just going to show that it changed my window now. Okay, so I actually have a graph that looks like this. Okay, so there's that root that I found earlier. Now I didn't really need to see this bump, but what ends up, if I expand my window, I can actually see, and I better write my window in, so negative 200 to 10. Okay, so this is a window that I'm looking at. There's my non-real solution. Okay, these represent non-real roots. I've got a real root right here at 7, but I want to be able to factor and find this non-real factor. Well, to do that, what I'm going to do then is, I know one of my factors is going to be x minus 7. Okay, so that's my real solution. Okay, I get that from there. If I want to find the other factor, what I'm going to do is I'm going to take my real solution and I'm going to divide. So I'm going to take my negative 7 I get my remainder of 0, which is exactly what I expect. Okay, and my non-real solution is a quadratic that looks like this, x squared plus 7. And that x squared plus 7 has no solution. There's no x's that make this equal to 0. So there it is. There's my quadratic non-real factor. And then again, that non-real solution has to come in pairs. So my factors then are x minus 7 and x squared plus 7. Okay, this is the factored form of this graph. Now, I could have done this without graphing. That would mean that I'd have to find this by guessing and do the same thing, but we could do that as well. For these ones, we're just going to practice graphing though. Okay, so I'm going to take a look at this one here. I'm going to graph this. I want to factor this expression. So I'm going to graph it. So I'm going to graph this expression, put it in my graphing tool. Okay, and I'm going to see what I get here. So I get a graph. And my graph looks kind of like this. So I'm just going to sketch it in. So I get a graph that kind of looks like that. Okay, and it looks like I have a real solution here at 2 and one at negative 1. Okay, so I have two real solutions, but this is a 4th degree polynomial. I need 2 more. So where are those 2 other ones? They don't show up on my graph as zeros. In fact, they're right in here. Okay, they're that kind of little funny looking shape in there. Okay, because we have 2 zeros, 2 arms that are kind of compressed in there that don't touch the x-axis. And those are going to be the non-real solution. So how do I find that non-real factor then? Well, from the real factors, I know that I have x plus 1, x minus 2, and I know I'm missing 2 more factors, so they must be quadratic. Okay, so it's probably going to be quadratic. How do I find that missing quadratic factor? Well, if I have this polynomial to start, and I divide by this, and I divide by this, I'm going to be left with the quadratic. So that's what I'm going to do to find it. I'm going to do my synthetic division. So what do we have here? I think I might have done something wrong. So this is going to be 1, yeah, 1 well, I'm missing my squared. That's my problem. Okay, so I forgot my my placeholder here. Okay, my place value, because I have x4, x cubed. I'm missing an x squared, so I need to make sure I put that 0 in there. Now this will work out. Okay, so I kind of was seeing that I wasn't going to get a remainder of 0, so I knew there's a problem there. Okay, so up to this point I think I'm okay. So 1 times 1 to minus 2, yeah. So this is going to be minus 2. 0 minus 2 is going to give me 2. Negative 2 minus 2 is going to give me the negative 4. Okay, and there now I have my 0 remainder. Okay, so I can do this again. I'm going to use the other factor, negative 2. So negative 2, 0, 0, 2, negative 4. I'm going to end up with a remainder of 0 again. So what ends up happening then is I'm left with this non-real solution of x squared plus 2. Yeah, that doesn't have a solution. Okay, that will never equal to 0, so there's no solution for that part. So now I have 3 factors, but I have all 4 degrees of the original 4th degree polynomial. And those non-real solutions end up showing up in there.